In example 2, we're being asked to solve for x, which is in the exponent, so we need to use a log. However, when we use logs, we need to make sure that the base, the argument, and the exponent are clearly defined. So we definitely have a base here. Okay, there's our base. Our exponent is here, but the argument is not clearly defined. So what we have to do is we're going to have to identify the argument parts of this. So this is an a. We have this extra a. So what we want to do is get rid of that a and put it with the argument side. So that's the first thing that we're going to do. So we end up with b, c as our base. Our exponent is x. And we're going to do d divided by a. Now at this point, we have our argument defined, we have our base defined, and we have our exponent defined. So now we can apply logs. So at this point, applying the log, we have log, the base is BC, the argument is D over A, and the exponent is X. That's what the log is going to be equal to. So now at this point, we've solved for X. In example 3, we're graphing this. So I've graphed the basic function y equals log base 2 of x. And what's happening here is we have a vertical expansion. Okay, so it's going to expand vertically from the x-axis. And then we also have a horizontal compression of by times 4. So the graph of this is going to end up looking like this. So our compression of 4 is going to put our x-intercept about there. And we're going to end up with a graph that's been vertically expanded and horizontally compressed. So it's going to look something like that. So we could also take this graph and we can rewrite it. And we can rewrite it like this. Y equals 3 log base 2 of 4. Well, log base 2 of 4 can be evaluated plus 3 log base 2 of x. So we still have our vertical expansion of 3, but we also have, when we simplify this, log base 2 of 4 is 2 times 3 is 6. So we end up with 3 log 2 of 4. There's our vertical expansion. But we also have a vertical shift of plus 6. So in this case here, we can see that that reference point, if we were to reference that point here, has been shifted up 6. Okay, and it does the same thing. Now, when we talk about the inverse is when we switch x and y around. Okay, so the x and y get switched around for the inverse. So I end up with y and x. I end up with x equals 3 log base 2 of 4y. I can solve for y, so I have to divide by 3 first. I'm going to convert this to exponent. So 4y is equal to 2 to the exponent for x over 3. And then I have my vertical compression factor of 1/4 and a horizontal expansion of times 3. So when I draw this graph, the graph of this, I'm just going to draw my reflection here. Okay, so when I draw the graph of this, it's going to be a reflection of that graph. And what color I'll choose here? I'll choose that one. So it's going to have a horizontal asymptote through there, and it's going to look something like this, coming through there as a exponential function. Okay, and so it's a mirror image in that green diagonal line.